In this video, we will go through a practical use case of deploying a managed Kubernetes cluster on Linode. We will deploy a replicated database and configure its persistence and make it accessible through a UI client from browser using Ingress. And we will use Helm to make this process more efficient. So you will see Helm in practice and some of its advantages. To give you a more detailed overview, first we will deploy MongoDB in Linode Cluster using Helm. We will create replicated MongoDB using StatefulSet, and we will also configure data persistence for a MongoDB database using Linode's cloud storage. We will then deploy a UI client, MongoExpress, for a MongoDB database in order to access it from the browser. And for this client, we will configure Nginx Ingress. So we will deploy Ingress Controller in the cluster and configure Ingress Rule in order to demonstrate handling browser requests in the cluster. And almost 100% of this whole setup is what you probably will always need to do when you set up your Kubernetes cluster, no matter which database or cloud platform you use. So you can use the concepts you learn here for many other use cases as well. So the first thing we'll do is create Kubernetes cluster on Linode Kubernetes Engine. So I have a clean state. I don't have any nodes yet. I don't have any volumes. It's all clean. So here from Create tab, I can choose Kubernetes. And this is a UI where basically you can give all the information for your Kubernetes cluster. Let's call it test. I'm going to choose a region which is closest to me. Kubernetes version, I'll choose the latest from the list. And this is a place where you can choose your nodes. So as I explained to you in the theoretic part of the video, managed Kubernetes service basically manages the master nodes for you. So you don't have to create or add master nodes. They're hidden away from you. You don't have access to them, and they're managed, including their security and backups, etc. You only need to care about the worker nodes. And this is a place where you choose your worker nodes. These are the capacities of different ones. So I'm going to choose the second one, actually, the 4 GB. And I'm going to choose number, or how many of those worker nodes I want. I'm going to choose 2, and I'm going to add that to my cluster. And here I see the capacity again, and I also see the monthly cost of that cluster. And create cluster. So basically this is all you need to do in order to create a cluster. This is all the information you need. Everything else will be done in the backend for you. And then you see this dashboard with all the information, and you see the progress basically of your worker nodes provisioning or being created. So we're going to wait until that creates. It takes actually just a couple of minutes to create the cluster. And here in the notifications, you actually see what's happening in the background. So you see, for example, your worker nodes got created, some configuration has been added, etc. So you see the nodes are running, they're ready. So now we have a Kubernetes cluster on Linode platform, and obviously we want to access it from our local machine, from our laptop, so that I can execute kubectl commands and deploy stuff on that. And in order to do that, I need access file or access credentials, and this is all stored right here. So you can download it. And this is what I have right here. So this file, basically, if you open it, you can see there are credentials for the cluster and also the certificate. So this will make it possible for you to connect to the remote Kubernetes cluster. So the first thing you want to do when you download this file is, I'm going to go to the folder where I downloaded it. So this is the kubeconfig file, and you have to set it as an environmental variable. So I'm going to do export kubeconfig and set the value to this file. And now if I do kubectl get node, I see my 2 Linode worker nodes. So I'm connected to this remote cluster, and I can now deploy stuff in there using kubectl command. And all you needed to do for that is set this variable. And you see the status of nodes is also ready. So we've created Kubernetes cluster, and we are now connected to it. Now, the second step that we're gonna do is deploy MongoDB StatefulSet in the cluster. So there are two ways to do that. The first one is we can create all the files or the config files necessary to deploy our MongoDB StatefulSet. This will be the StatefulSet config file itself. This will be the two services that we need and maybe some configuration as well. And in order to do that, we need to find the image, the version for the StatefulSet, or maybe Google and find correct configuration for MongoDB, like a script that synchronizes the pods of the StatefulSet and so on. Or the second option, the easier one, is we find a bundle of those configuration files that somebody already created, tested, and is managing or maintaining, and use that file so that we don't have to figure out all the details. And that bundle could be a Helm chart. So whenever you have this situation where you need to deploy a StatefulSet, for example, which has a lot of configuration details, the first thing you can do is search if there's a Helm chart for it. So I'm gonna look for MongoDB Helm chart. And currently the maintained MongoDB chart, Helm chart, is managed by Bitnami. By the way, if you don't know exactly what Helm is and Helm charts are, I have a separate video about that where you can learn exactly what Helm is, what are the advantages of it, and then you can come back to the video and see how to actually use it in practice. Okay, so the first thing I need to do is add the repository that contains my Helm chart. So I'm gonna go back and I'm gonna execute this Helm command here. Now, you have to install Helm if you don't have it yet. And one thing to note here as well, when I execute Helm command, it is gonna execute it against the cluster that I'm connected to, right? So we connected to the cluster, so now we can execute kubectl and also Helm commands against that cluster. So Helm will use kubectl in the background. So I'm gonna add Bitnami repository. It has been added. And what I can do now is I can do Helm search repo Bitnami. And I can see all the charts that this repository contains. And let's actually search for MongoDB. And these are the two. So I have MongoDB chart right here. I see the version of the chart and the version as well. So this is our chart. This is what we're gonna install in our cluster. Now, when you're installing a chart, there might be some values that you want to override. So chart provides you some default values and you want to see, or you want to check what parameters or what values you can override. So let's go back to the browser and let's see what parameters we have available. So let's check MongoDB, and this is all the description for the chart. And here are the parameters. So the first thing that we're going to do is we're going to define that we want to run a StatefulSet, right? So because we want to replicate our MongoDB database, we don't want just one pod, we want multiple replica pods. So we're going to set this to replica set. Another thing that we're going to do is pass root password or set the root password ourselves. If not, it will just create a random one, which we can also access later. So that's our choice. And another thing that we want to override here is the volume configuration. So we want the chart to use the storage class of Linode Cloud Storage, because we want it to connect to Linode and create volumes or physical storage on Linode and attach it to our pods. This may sound a little bit complicated as a concept, but you as a user, you don't have to do much for it. It's just one line and everything else is done in the background. Now, if you want to learn more about stateful sets or what persistent volumes or storage classes are, I have separate videos on all of those topics, so you can check them out. Right, so how do we actually pass those parameters to our chart? So how can we override some values that are defined in the chart already? And we do that in Helm using a values file. So I'm going to go back and create a file that will override some of these parameters. So I have the file created already. This is a YAML file, and these are the parameters So this is just a YAML file with key value pairs defined to override those parameters. So I have architecture, which is replica set. Replica count is going to be 3. So when you set it to replicate, then you can use all of these parameters for StatefulSet. So I set replica count to 3. And in persistence, I use storage class Linode block storage. Right? So let's go back and see persistence parameters. So persistence dot storage class, and this is how I define it here. And the value of it is Linode block storage. So this is everything you need to do in order to configure persistent volume for your MongoDB. This is easy as that. So what this will do is in the background, it will connect to Linode and it will create physical storages using Linode Cloud Storage and attach it to your pods. Again, if you don't understand these concepts, you can watch my video about storage and you will have a better understanding there. And we're also overriding the root password. So we have everything ready. We have the chart and we have the values that we use to override some of the parameters of the chart. So now all we need to do is execute the command in order to install the chart using those override values. And that command is Helm install. And then I define an arbitrary name that I want to give MongoDB in my cluster. So let's call it MongoDB. And this is where we pass these parameters file that we created. So this is going to be values flag, and I have that file in downloads folder. So let's see, that's test MongoDB. That's the file. And finally, we are going to provide the name of the chart. So this is the name, repository / chart name, and this is the complete command. So install, this is the name that we give our MongoDB StatefulSet, the values file as a parameter, and the chart name. So when I execute this, it will install that MongoDB chart in my cluster. And you see I get some additional output of the status. So it basically started to deploy them. I have 3 replicas as I provided here, and each one of them gets their own service. So now let's actually check what is happening in our cluster, and you see that our pod replicas are being created. So this can take a little bit of time. So we clear this up. Okay, so it must be started already. And as you see, I have 3 pods of MongoDB running, plus there is another pod that manages the replication between those. But again, you don't have to worry about the details. You don't have to know how the whole thing is done, because this gets updated as well all the time. That's why it's much more practical to use the charts instead of trying to patch together your own configuration files. Okay, let's also see what other things got created. So I'm just gonna print out everything in the default namespace. So in addition to our pods, you see the services. We have 3 MongoDB services that have been created. And one of them is MongoDB headless service. Again, I'm not going to go into much detail to how StatefulSet and services work because I made a separate video on them. So go check that out if you haven't seen that already. And the StatefulSet, of course. And this is the name that we gave when installing the Helm chart. It's called MongoDB. And what we also have is a secret of MongoDB that actually contains the root password that we provided here. So now what about the persistent storage? Let's actually head back to Linode UI and let's go to, first of all, in Linodes, you have those 2 worker nodes and their status. If you click in one of them, you can see all the configuration there, like IP addresses, etc. And in volumes, you see it was empty when we set up the cluster. And now we have 3 persistent volume components that were dynamically provisioned or created. So basically this configuration right here, Linode block storage, defined as storage class, what happened is that when the StatefulSet was created. For each pod, a physical storage was created for each of the 3 pods. So this is the physical storage somewhere on Linode servers, and for each physical storage, a persistent volume was created, and that is now attached to the node where the pod is running. We have only 2 nodes, so these 2 are the same, and this is a second node. So again, we didn't have to do much here. Everything is configured pretty easily. And now we have a replicated MongoDB with its persistent volume configured in the cluster. Now the next thing we're going to do is deploy MongoExpress, which is going to be the UI for MongoDB. Now, since MongoExpress is actually just going to be 1 pod, so we don't have to replicate it, and it's going to have 1 service, it's pretty straightforward. I actually went ahead and created own configuration file. I don't need to search for a chart or anything there because it doesn't have so many parts. So this is the file. And by the way, all these files that you see here, I'm going to put them in a Git repository and link them in the description so you can use them as well if you want to practice along with this video. So this is very simple, straightforward deployment configuration. We have MongoExpress name everywhere, and this is our container. So we take the latest MongoExpress image. It's going to run on port 8081. And this is the configuration for connecting to MongoDB. And these are the environmental variables configured so that MongoExpress can connect to MongoDB database. And if you're asking where I got these environmental variables from or how do I know what they're called, you can check out the MongoExpress Docker file. It comes with the documentation of how it works. And here are all those environmental variables. So it's pretty easy to find that out. And also, if you want to fixate the version, you can choose one of the tags. I'm just using the latest. Okay, so we have configured username, the admin username, which is root by default, and we have admin user password. This is what we configured here. And because those YAML files are usually checked into the repository, it's not a good practice to write passwords directly. So we are getting it from the secret, right? And this is a syntax for it. Again, I have a separate video about that if you want to check that out. So I'm not gonna go into syntax details, but just very quickly, I'm taking that root password value from the secret. This is a secret that we saw before. So this secret actually contains, we can check that, MongoDB. Like this, you can check the values inside. So we have 2 key pair values. We have the replica set key, we don't need that, and this is the root password key. So MongoDB root password, that's how I'm accessing it. And the third one, this is also an important one, is the value of MongoDB server. So this is the endpoint where MongoExpress will connect to MongoDB pod. And this is the pod endpoint. This is the pod name, and this is the headless service name. So this is how the endpoint looks like. This concept is also covered in a StatefulSet video, so you can learn it there. So I have the endpoint, user, and password in order to connect to MongoDB. Let's look at the service. Also very straightforward. It's an internal service, so it's not accessible through browser. It's only accessible within the cluster. It listens on port 8081 and sends the request to the pod on port 8081. So this is the target port right here. So this is all we need to configure MongoExpress. And I'm gonna create that in the cluster. So let's clear that actually. kubectl apply. Like this. So now we have the MongoExpress running as well, and container will create. So when it successfully connects to MongoDB, it will have a running state. So let's check again. And as you see, it's running. We can also check the logs to be sure. Logs. Admin database connected. Cool. So we have MongoDB running in the cluster. The data is being persisted, and we have MongoExpress, so we can access the MongoDB UI. However, as you saw, the MongoExpress is internal service, so we have to open it to the browser for external requests. And we're going to do that using Ingress. So the next step will be to install Ingress Controller in our Linode Kubernetes cluster. And let's see how that works. So now we're going to deploy Ingress Controller in our cluster. Ingress Controller also has some different components. So instead of creating the configuration file ourselves for it, we're going to use Helm chart for Ingress Controller as well. And I believe there are a couple of different Helm charts for Ingress Controller. We're going to deploy the Kubernetes managed Nginx Ingress Controller. And I already found a Helm chart for it. So I'm going to add the repository first of that Helm chart. It's been added, and now I'm going to execute the installing of the Helm chart. So again, the name that I'm giving to this component, this is the chart name from the repository. So it's stable Nginx Ingress, and I'm passing in some attribute or some parameter. And here again, we see the output. This is a example Ingress Rule file. And we can now check that the Ingress controller was deployed. You see 2 Nginx Ingress pods are running here. The one is just a default backend if no rule is configured, and the controller itself. So this means that now we can actually create Ingress rules in our cluster. So now we can define the domain name or host name that will then route to some Kubernetes service. Now, as I also explained in the theoretical part of this video series, Ingress Controller uses some cloud native load balancer in the background. So if I go back to Linode's UI, and if I go to node balancers, this is Linode's own node balancer or worker node balancer that was dynamically created and provisioned as we created the Ingress controller. And as I explained, this node balancer becomes the entry point into our cluster. So this node balancer basically gives us the external IP address. This is the one accessible from browser. We have the ports open on it, the 80 and so HTTP and HTTPS ports. And the node balancer will then forward the request coming into the cluster, then to the Ingress controller and to our internal services based on the Ingress rules that we create. So let's go ahead and create the Ingress rule for our MongoExpress service so that we can access it from the browser. We can also see that Nginx Ingress service was created. So let's see, service. And here we have the Nginx Ingress controller service. And as you see, the type is load balancer. This basically means that this service is accessible externally, and the cluster IP services are internal services. So they're not accessible from outside the cluster. And the external services also have external IP address in addition to the internal cluster IP address. And this IP address is actually the same as the IP address of the node balancer. So as you see here we have the IP address of the node balancer, and this is the same one as this here. So as I said, this will act as an entry point into our cluster and will forward the requests based on the Nginx rule that we create to respective service. So now we're going to go create Ingress rule for MongoExpress service so that we can access it from the browser. So this is the Ingress rule that we're going to create. We're going to call it MongoExpress. And the first thing we need to configure is the host. So host has to be a valid domain address. It cannot be an IP address. So this is the first value that we're going to get. So the host is basically a domain address that is connected to your cluster. So I'm going to go back to Linode and the load balancer. I have the host name of the load balancer as well. So I'm going to use that one. But in production, for example, in normal case, you would have your application domain, so myapp.com or whatever it is. So basically you have to configure the domain wherever it's hosted to point to the IP address of the node balancer, so that whenever someone types the domain address in the browser, the domain name server will resolve that domain name to the IP address of your cluster entry point server, right? So I'm just gonna go with the host name that I have for the node balancer because it's already pointing to the IP address. And I'm going to go back and paste that in. So I have my host. And here we basically define a HTTP forwarding of request that's coming from this domain to our internal service. So request came into the cluster from this domain on that path, on the root path basically, and we are forwarding it to service name called MongoExpress service. This is the service name which we created here, the internal service on the service port 8081. This is where the service MongoExpress is listening to. And this will be it for the Ingress file. So let's actually apply that in the cluster. Let's clear that. kubectl apply. And our ingress is created as well. Let's actually check that. That's our ingress rule. So now, if I copy that, this is the domain that we defined in our ingress rule. So when I access this domain, I get MongoExpress UI. So now, again, for clarification, I typed in the host name that I configured in my Ingress rules in the browser. This host name was resolved to the IP address of Node Balancer, which is the external IP address of my cluster or entry point of my cluster. So now the Ingress controller looked at the request and looked at the Ingress rules that it has inside the cluster and actually resolved that request must be forwarded to our internal service called MongoExpress service at the port 8081. And that's how the whole request flow happened in the cluster, and that's why we see MongoExpress UI under that host name. So now I can create a new database. You can see it here, and update some stuff as well. So everything works. I have my database here, and these changes will also be persisted because we have data persistence configured as well using the volumes. So this means that if I now delete the pods and restart them, the data will still be there. So let's actually do that now. I'm going to scale down the StatefulSet called MongoDB to 0 replicas. Let's check that. Get pod. It's terminating. So all the pods are gone. So now I'm going to scale it back to 3. So this means the containers inside, so the pods and the containers inside will be created again. So if I go back to Linode, you see that the volumes were unattached. And now as the pods are creating again, they're reattaching the volumes that belong to them, which is a good thing because on the new start, on the restart, they basically get the same data that they had before they were stopped or they were removed. So all of the data is reattached to those pods. And now if I'm done with the chart, for example, or for example, if I want to reinstall my charts or update or whatever, I can also uninstall it pretty easily using Helm. So with Helm ls, I see on my charts here, I have MongoDB and Nginx Ingress. So I can do Helm uninstall MongoDB. And the great thing about it is that if you manually created all those components like secret, services, pods, StatefulSet, etc., you would have to go and clean up all those stuff manually, or you would have to know what was created and remember so that you can remove them as well. With Helm, basically uninstall does the revert of install. So this is another advantage of using Helm charts actually. So now after uninstall, you see all the volumes got unattached again. So I don't have MongoDB StatefulSet running at all in my cluster. All the components were deleted, but I still have the volumes, or I still have the data in case I restart them or reinstall the StatefulSet. And this is a security feature because you may not want to lose the data when you delete the application. And if you don't need those, you can actually just go and delete them. And also, if you're done with cluster, you don't have to go and delete all those components like volumes and workers, etc. You go to your Kubernetes, delete the whole cluster pretty easily. Or maybe if you've corrupted cluster, I don't know, you tested around some stuff and kind of got messed up, you can basically delete it and start from scratch. So that's it for the demo. I hope you also practiced along and you were able to create the same setup. If you got stuck somewhere or if you have any questions, please write them in the comment section below and I will try to answer as many questions as I can. Thank you for watching this video and see you in the next one.